The Artemis II mission came home on April 10, 2026, and in the weeks that followed, NASA began releasing the processed images from the mission archive. What came out of that archive was not what most people expected. Everyone had seen the headline photographs already. The Earthsat image. The eclipse shot. The Earthrise frame. Those three images went viral the moment they were transmitted home through the laser communication system aboard Integrity. But those three images were only the surface of what the Artemis II crew actually captured during their 10 days in deep space. The full archive contains thousands of images, and as NASA processes and releases more of them, the collection keeps getting deeper. This is the updated breakdown of the best Artemis II moon images, covering not just the famous ones but the ones that came after, the ones that took longer to process, and the ones that deserve far more attention than they have received. The first thing to understand about the Artemis II moon images is how they were made possible at all. The spacecraft Integrity carried 32 cameras aboard. 17 of those were handheld units that any crew member could grab as needed. The primary camera was a Nikon D5, a professional digital camera that the crew used for most of the serious photography work. There was also a Nikon Z9 mirrorless camera for specific situations, several GoPro action cameras, and 4 iPhone 17 Pro Max smartphones. This combination of equipment, combined with the zero-atmosphere environment of deep space, gave the Artemis II crew photographic capabilities that no Apollo mission ever had. Every image that came through a window on Integrity had no atmospheric interference between the lens and the subject. No haze. No turbulence. No bending of light. What the camera saw was exactly what was there. That condition alone makes the Artemis II moon images categorically different from anything photographed from the surface of the Earth. The updated image releases also include something that was not initially discussed much in the media coverage. Many of the best Artemis II moon images were shot during the 7-hour lunar observation window on April 6, and a large portion of those images were targeted specifically by scientists on the ground. Researchers at Johnson Space Center in Houston were on the radio calling out specific areas of the lunar surface for the crew to photograph. They asked for images of specific crater formations, shadow patterns, bright ray systems, and geological features. The crew delivered. The result is not just a collection of beautiful photographs. It is a scientific dataset. The best Artemis II moon images are simultaneously art and data, and the updated releases include many of the scientifically targeted images that did not make the original headline roundups. The Earthsat image is the one that most people think of first when the Artemis II moon images come up. It was taken at 6:41 in the evening on April 6 and is catalogued in the NASA archive as AR-002E00287. The image shows a thin blue crescent of Earth sinking below the cratered horizon of the Moon. The day side of the planet is visible over Australia and the ocean to its south. The Earth is small. The Moon fills the foreground with its gray and brown surface, heavily cratered, ancient, and rough. The crater that appears prominently in the foreground has terraced walls and a central peak structure that speaks to the enormous impact that created it billions of years ago. What makes this image the best of its type is the proportion. Earth is tiny. The Moon is enormous. This framing tells you exactly where the crew was and exactly what their relationship to both worlds was in that moment. They had left one world behind and they were passing the other at a distance of less than 5,000 miles. The updated releases include additional frames from the same sequence showing slightly different positions of the Earth as it continued to set behind the lunar horizon. These additional frames have not received the same attention as the primary image, but they show the full motion of the set, which gives a sense of how quickly Integrity was moving relative to the lunar surface. The eclipse image is the one that photographers and astronomers reacted to most strongly when it first appeared. During the Artemis II flyby, the alignment of Integrity, the Moon, and the Sun produced a total solar eclipse that lasted nearly 54 minutes. From the crew's position in space near the Moon, the lunar disk appeared 5 times larger than the Sun in the sky. The Moon blocked the Sun completely, and the solar corona appeared around the dark disk as a glowing halo of light. Stars became visible in the black sky around the eclipsed sun. Venus appeared as a sharp bright point near the lunar edge. In other frames from the same sequence, Saturn, Mars, and Mercury were also visible. The primary eclipse image shows the corona in full detail, with the texture of the corona's plasma structure visible in the outer edges. This image is impossible to replicate from Earth. Ground-based solar eclipses last 2 or 3 minutes at most, and during that window the corona is visible only briefly before the alignment shifts. The Artemis II crew had 54 minutes of totality. They shot the eclipse from multiple angles with multiple cameras, and the updated image releases include the longer exposure frames that show more of the corona structure than the original release did. These additional eclipse frames are among the most scientifically valuable images in the entire Artemis II moon images collection. The meteoroid impact images deserve their own section because they represent something genuinely new in the history of space photography. During the eclipse window on April 6, while the sunlight was blocked and the lunar surface was in shadow, the crew watched the dark surface of the moon and began to see flashes. 6 times during their observation window, small white flashes appeared on the darkened lunar surface. Each flash lasted only a millisecond. Each one shifted from white to blue-white as it faded. These were meteoroid impacts, pieces of space rock hitting the moon at extreme velocity, releasing a brief burst of light on contact. Scientists at Johnson Space Center erupted when the crew started calling them out over the radio. The science team described audible screams in the room. Meteoroid impacts on the moon happen every day, but nobody had ever watched them in real time from a crewed spacecraft with the naked eye. The Artemis II crew confirmed 6 of them. The video frames and still images from those moments are not the most beautiful images in the Artemis II moon images collection. They are small, they are brief, and the flashes are tiny against the dark surface. But they are the most scientifically significant images in the entire archive, because they show something that had never been directly observed from a human crewed position before. The updated releases include enhanced processing of these frames that makes the impact flashes more visible than they appeared in the original footage. The Earthrise image is the one that the crew prepared for most deliberately. It was taken at 7:22 in the evening on April 6 and is catalogued as AR-002E021278 in the NASA archive. It was shot with a 400mm telephoto lens through Integrity's window after the spacecraft came back from behind the moon following 40 minutes of radio silence. The crescent of Earth reappears above the curved dark horizon of the moon. The crew had trained specifically for this photograph. They knew that the world would compare it to the Earthrise image taken by Bill Anders during Apollo 8 in 1968, and they wanted to produce something worthy of that comparison. The 1968 Anders image showed a half-lit Earth rising above the lunar horizon in a horizontal frame. The Artemis II version shows a thin crescent Earth because of the crew's position relative to the Sun, but the composition and the emotional weight of the image are directly connected to the same tradition. The updated image releases include a wider sequence of frames from this moment showing the Earth rising progressively above the horizon. When played as a sequence, these frames give a sense of the true motion of the spacecraft as it came around the lunar limb and Earth came back into view. The silence that preceded this image, 40 minutes of no contact with anyone on Earth, makes the reappearance of that crescent planet above the horizon one of the most emotionally loaded moments in the entire mission. The far side images are among the most historically significant in the Artemis II moon images collection and also among the least discussed in the initial media coverage. When Integrity passed behind the moon on April 6 at 6:44 in the evening, the crew lost contact with Earth for 40 minutes. During those 40 minutes, they were on the far side of the moon. They had cameras. They used them. The far side of the moon is fundamentally different from the near side. It has no large dark plains, the kind of flat ancient lava fields that make up the dark patches visible from Earth. Instead, it is heavily cratered across almost its entire surface, older and more rugged, a landscape that speaks to the early violence of the solar system when impacts were far more common than they are today. The Artemis II far-side images are the first far-side photographs taken from a crewed spacecraft since the final Apollo missions in the early 1970s. The updated releases from this part of the archive are particularly significant because the initial image drops focused heavily on the Earthrise and Earthset images and the far side coverage was released more slowly. The far side images now available show crater fields of enormous scale, the kind of surface complexity that robotic orbiters have mapped in detail but that the Artemis II crew could now see with their own eyes and photograph with professional cameras at close range. The shadow images are a category that emerged more clearly in the updated releases. As Integrity traveled across the near side of the lunar surface during the 7-hour observation window, the crew photographed regions where the sun was low on the horizon relative to the surface below them. At low sun angles, the shadows cast by crater walls and mountain ridges stretch for enormous distances across the surface. These shadow images reveal the three-dimensional structure of the lunar terrain in a way that overhead sunlit photographs cannot. A crater that looks like a simple circle from above looks completely different when the sun is low and the shadow of one wall stretches halfway across the interior floor. The Artemis II moon. Images from the shadow photography sessions are some of the most geologically informative images in the collection. Scientists studying lunar topography have identified surface features in these shadow images that were not well understood from existing orbital data. These are not the images that went viral. But in the updated archive, they stand out as some of the most useful photographs the mission produced. The crew portrait images taken during the flyby are different from the standard crew portraits taken earlier in the mission. During the 7-hour window, the crew was working. The photographs that caught crew members during this period show people doing something specific, holding a camera up to a window, leaning toward the glass to look at a feature below, talking to the ground through a headset while keeping eyes on the moon outside. These images capture what it actually looks like to be a human being doing scientific observation work from a spacecraft in lunar orbit. They are not posed. They are not staged. They are documentary. The updated releases include a number of these working portraits that were not part of the initial image drops, and they provide a human context for the technical images that makes the collection feel complete. When you see a close-up of a crater on the lunar surface and then you see a photograph of the person who took that image, leaning into the window with a professional camera, you understand something about the relationship between the human being and the photograph that you cannot get from the image alone. The laser communication system that brought these images home is itself part of the story of why the updated releases keep coming. The system aboard Integrity was called O20, which stood for Orion Artemis II Optical Communication System. It transmitted data at a peak rate of 260 megabits per second, which is roughly equivalent to good home fiber internet speeds, except that the fiber in this case was an infrared beam crossing hundreds of thousands of miles of empty space between the spacecraft and a receiver dish on the ground in New Mexico. This system transmitted the initial headline images quickly. But the full archive of approximately 10,000 images from the flyby alone, plus hours of 4K video, required time to fully downlink and then additional time to process. This is why the updated image releases have been coming out in waves rather than all at once. The images are there. The data came home. The processing takes time. The best Artemis II moon images are not just the ones that went viral on the day they were released. The best ones include images that are still being processed, still being cataloged, still being studied. The eclipse sequence that lasted 54 minutes produced more frames than any single viral image can represent. The far side coverage from 40 minutes of silence behind the moon is deeper than the handful of images initially released. The shadow photography from the 7-hour observation window contains geological data that researchers are still working through. The meteoroid impact flashes, caught on video and in photographs, are being analyzed frame by frame. This is a collection that will continue to reveal itself over months and years, not just in the days after splashdown. The updated Artemis II moon images are not a finished product. They are an ongoing release from the deepest crude photography session since the Apollo era, and what has come out so far represents only the beginning of what the archive actually contains. The moon has been waiting 50 years for this kind of attention. Integrity delivered it. The color calibration images are a category that most casual viewers of the Artemis II moon images will never seek out, but they matter for understanding the full scope of what the mission produced. Before the crew photographed the lunar surface, the cameras aboard Integrity were calibrated using color reference targets inside the cabin. This calibration process means that the colors in the Artemis II moon images are as accurate as current technology allows. The gray of the lunar regolith in these images is the actual color of the surface. The slight brown tones in some regions are real. The very faint hints of color variation between different geological areas of the moon are not artifacts of the camera or the lighting. They are real color differences in the surface material, visible because the cameras were properly calibrated and because there was no atmosphere between the lens and the surface to shift or distort the color information. Some of the updated image releases include side-by-side comparisons of the same surface features at different sun angles, which allows scientists to study how the color and brightness of lunar materials change depending on the direction of illumination. The sequence of images showing the Terminator line is another part of the updated Artemis II moon images collection that has not received enough attention. The Terminator is the boundary between the sunlit side and the shadow side of the moon. From Integrity's position during the flyby, the crew could look down at this boundary and photograph the transition from full sunlight to total shadow across the lunar surface. Along the Terminator, the shadows are at their longest and the surface texture is most visible. Small features that would be invisible under direct overhead sunlight become dramatically clear when the light is raking across them at a low angle right at the Terminator. The Artemis II images along the Terminator line show the lunar surface in a way that gives you a physical sense of its texture, the roughness of it, the way the soil is piled around old impacts, the way ancient geological processes have shaped and reshaped a surface that has been sitting in space for 4 billion years. The final image of the mission that belongs in any discussion of the best Artemis II moon images is actually not a moon image at all, but it is connected to the moon in a way that matters. It is the photograph taken through Integrity's window on April 7, the day after the flyby, showing the moon receding in the distance as the spacecraft began its long trip home. The crew had just completed the most intensive photography session in the history of crewed spaceflight. They had just become the first humans to see the far side of the moon in over 50 years. They had watched meteoroids hit the lunar surface with their own eyes. They had shot the sun disappearing behind the moon for nearly an hour. And now, in this single frame, the moon was getting smaller. It was going back to being the thing in the sky that everyone can see from Earth. The crew had been close enough to photograph its craters individually. Now they were leaving. This image of the moon in retreat, taken the day after the best moon photography session ever conducted by human beings, is the closing frame of what the Artemis II moon images actually mean. The moon was visited. It was documented better than it had ever been documented by human-operated cameras before. And then the crew came home, bringing with them an archive that the world is still working through.